Good morning.
Good morning.
All right. Okay, so let's get into it. Let's focus on determining pKa and Kas and pHs. So in the lab, we're going to be dealing a lot with pH and pOH and pKa and all of that as well. So let's talk about what a pH and a pKa and all that actually are. If we're talking about pH, I've got it here, it's the negative log of the H plus, or the hydrogen ion concentration. And when we're talking about this little p here, the little p actually means simply take the negative log. So minus log of something is what the little p means. So pH is negative log of H plus, pKa is negative log of Ka, pOH is negative log of OH minus. So generally speaking, when we're talking about hydrogen ion concentrations, we're usually talking about something in the range of something where it's Z times 10 to the negative Y, like a 4 times 10 to the negative 6 or 5 times 10 to the negative 3, that kind of thing. And because we're taking the log of something, a rule of thumb would be that the pH then would be approximately, it's not going to be exactly, but it'll be close to Y. Because when you take the log of 10 to the anything, that value is X. So the log of 10 to the X is X. So the inverse of log is 10 to the power of. This is something you hopefully learned back in college algebra or something like that, but that's the link between log and 10 to the power of. So we often call log, as we often call 10 to the X, is often called the inverse log. So if you look at your calculator, often what you'll see is you'll see the log button, and then above it, you'll see 10 to the X. And that's the second function of a log. It's the inverse of the log. And you can flip between them and they'll give you the same number if you flip back and forth. The other number, of course, you'll see on your calculator, or the other one, is ln, and the inverse of that is called e to the x. So that's a different kind of log. That's a natural log. So you need to be careful not to mix those two up. And if we're dealing with pHs, then we're always dealing with log and not ln. So just make sure you're aware of that. Does anybody have any questions so far? Okay. So what we know about water is that when you've got just regular garden variety water, a very, very small amount of it will split apart into H plus and OH minus. And we can write a K expression for that. And if you remember what we did were, when we were doing test 1, we would do products over reactants. Now it turns out that the concentration of water is a constant value, because there's just so much of it in any given aqueous solution. It's a constant value. We can actually measure it. It's going to be, if you look at the units for concentration, be moles per liter. And if we know we've got 1 liter of water, that's about 1,000 grams of water, which happens to be around about 55.5 or 55.6 moles. And that would mean that the concentration of H2O is a pretty constant value of around 55.6 moles per liter. So as such, it's tied into the K value, which is also a constant value. So we end up with this constant called Kw, which ties the water up within that constant. And we end up getting H plus times OH minus. So that's what Kw is. Now we can do a little bit more math here. And we can say that Kw actually has a value of 10 to the negative 14. Now, if you think about why that's important, let's look at pKw. pKw would just be 14. Remember, you can just look at the exponent here, take the negative log of that. You can try it in your calculator if you like. 1 times 10 to the negative 14, you take the log of it, you'll get negative 14. You take the negative of that, and it'll be 14. And you know why that is an interesting number? It's because this is the top of the pH scale. Because we know that the pH scale runs from 1 to 14. We talked about this earlier when we were dealing with the titration curves. So that's the top of the pH scale of 14 now. And so that's the relevance of that. Now the other thing is, if we go back to our reaction here, we've got H plus and OH minus here. We get one of each when any given water molecule does split apart. And what that means is we can actually say, well, 10 to the negative 14 then. So H plus, the concentration of H plus equals the concentration of OH minus. Then we can say that the concentration of H plus squared is equal to 10 to the negative 14, which H plus then would be 10 to the negative 7. And that would also be the concentration of OH minus as well. But the pH then would be 7. And that's relevant because we know that pH of water, just neutral garden variety water, is going to be 7. So that's where the neutrality comes into play, is because of what I'm just showing you here, that H plus and OH minus are the same. We take the square root of 10 to the negative 14, we get 10 to the negative 7. We take the pH, we get 7. So that's where that comes into play. Does anybody have any questions so far?
Where's the H plus squared coming from?
Well, if H plus and OH minus are the same, right, they equal each other, then the OH minus can be substituted for H plus. Do you see that, Jez?
Okay, so it can just replace it basically?
Well, yes, because H plus and OH minus are the same. They're equal concentrations. So if they're equal values, then the concentration can just be substituted in.
Okay, thank you.
I have a question as well.
Mhm.
So I understand the whole, like, you have two H pluses because they're equal, but you said you take the square root of negative 14 to get 7.
Mm-hmm.
Is that because it's a 2?
Well, it's because it's squared, and if you
Okay.
take the square root of -10 to the negative 14, you'll get 10 to the negative 7. I mean, you can try it in your calculator,
Okay.
and you'll see that that'll be the case. So it's not 2 times h plus, it's h plus times h plus, because of up here h plus times OH minus, and we're replacing that with h plus. That's where the squared comes in. Is that okay, Alexandra?
Yeah, that makes sense.
Okay. Now the other thing we can do is we can talk about 2 other constants that now relate to specific situations. We've got Ka, which has to do with acid specifically, and acid involves H plus. So the A here is standing for acid. We have another one that we'll deal with as well called Kb, which is base, and this is all about OH minus. So whenever we're forming H plus, we're talking about the acid constant. Whenever we're forming OH minus, we're talking about the base constant. So the way that works is we can do, for the acid, we can do HA gives H plus A minus, or we can do HA plus H2O gives H3O plus A minus. So Ka will equal HA, sorry, start again. Ka will equal H plus times A minus over HA, or Ka equals H3O plus A minus over HA. You'll notice that the water here is going to be ignored because the concentration of water again is constant, so we don't have to worry about that. But the upshot of all of this is that H plus and H3O plus are really the same thing. The only reason that H2O hasn't been included here is because it's assumed that it's here. We're always talking about aqueous solutions when we're dealing with acids. But there's 2 ways of expressing it. You could either just say HA gives H plus A minus, or you can include the water. But if you include the water, then to balance it, it's going to be H3O plus instead of just H plus. But if you look at what H3O plus is, it's really just H2O with an H plus attached to it. So both of those are going to be equivalent. And I'm going to use them interchangeably, and you need to be prepared for that. Does anybody have any questions so far? So you'll notice that with base, it's the production of OH minus, and generally speaking, well, I'll give you two situations here. We can do AOH, where we've got actual OH minus in the solution already from the compound, or we can do this. We can say A plus H2O gives AH plus OH minus. And in that instance, for this one, the Kb is going to be A plus times OH minus over AOH. We won't see this that often. We'll see this one a lot more commonly. And the Kb, again, we ignore the water, and it'll be AH plus times OH minus over A. So you'll see this one a lot more commonly, but the point is with the base, what you're seeing in the KB product, or the KB the KB equation here is OH minus and not H plus by itself. So that's the upshot of all of this. So Ka is about acid, and we're looking at H plus, and Kb is base, and we're looking at OH minus, but that OH minus comes from the water, and we'll see how that happens in a little bit. Does anybody have any questions so far? That's all I want you to get so far. Ka is acid, Kb is base, acid is H plus, and B is and base is OH minus. Any questions? I think someone was going to ask something. No? Okay. Now, we have done K calculations before. We did it back in test 1. We can also do Ka calculations as well, and these are actually a little bit simpler than just regular K calculations. So here is the question. It's the pH of a 0.20 molar solution of HF is 1.92. Determine the pKa for HF. So we can actually, using this information, get an actual K value. The pH value is assumed to be at equilibrium. The 0.20 molar would be the initial concentration of HF. So the first step, you see, the thing is you're not given the equation here. You have to figure out how this splits apart. Now I'm going to show you 2 ways to do this, and both of them are completely equivalent. So we've got HF. The thing is, we're looking for Ka. So that's how I know, that's my signal that I have to use H plus. But if I'm forming H plus here, then the rest of it has to be F minus. The other way would be this, H2O plus HF gives H3O plus F minus, and that's going to be the same, the very same thing. So the initial concentration is still going to be 0.20 molar for the HF, 0 and 0 on the H plus and the F minus. This is very, very much like what we did in test 1. At equilibrium, we got this same deal going, 0.20 minus Z, Z, and Z. That's what we're going to have here. Does anybody have any questions? So looking at the Z's here, this is all very simple, because if you're talking about initially, all you're going to have is just HF in solution. But if, let's say, at equilibrium, and I'm just making this up here, the HF breaks apart, or 2 of them break apart, you can see that for every HF that breaks apart, we get 1 H plus and 1 F minus. So if Z molecules of HF broke apart, then we'd get Z molecules of H plus and Z molecules of F minus. Does anybody have any questions about this? You can see we've lost 2 HFs, but we've gained 2 H pluses and 2 F minuses. And you can see that here. We lose Z HFs, we'll gain Z H pluses and Z F minuses. Anybody have any questions? Okay. So we actually do have some information here that allows us to calculate the Z value. And that value is the pH, which happens to be the pH at equilibrium. You need to assume that though. So pH is equal to the negative log of H plus. Now, if I rearrange this, you can see negative pH will equal log of H plus. And then if I want to isolate the H plus will be 10 to the negative pH. Does anybody have any questions? it's like I told you about earlier with the calculator. If you look on your calculator, the button above the log button, the log button, is 10 to the x. So we take the negative first, and then that goes on negative pH. So if I want to calculate the concentration of H plus here, it would be 10 to the negative 1.92. So in your calculator, what you would actually put is minus 1.92, and then, I don't know, it depends on your calculator, but you'll hit the 10 to the x button. So what I'd like you to do is try that on your calculator. I mean, obviously, if it's a graphing calculator, you could do 10 caret negative 1.92, or you can do inverse log and then negative 1.92 and hit equals. That'll work as well. So either way, does anybody have any questions about getting that value of H concentration of H plus? I think it comes out to be 0.0120. Anybody got any questions about how to get that? So try it now on your calculator. Make sure you're getting the same thing. Any questions? All right, so just shortcutting that a little bit. So the concentration of H plus is going to be 10 to the power of the negative pH, which is 10 to the negative 1.92, which comes out to be 0.0120 molar. So then that actually becomes our Z value, because the equilibrium concentration of H plus is indeed Z, and you can see that here. So that's Z. We've got our Ka, which is going to be H plus or H3O plus, it doesn't matter which, times F minus over HF. And the Ka is going to be calculated based on that. So it'll be Z squared, whoops, over 0.20 minus Z. Now the Z squared is going to be 0.0120 squared over 0.20 minus 0.0120. Now, for significant figure purposes, that's a subtraction. That's going to go based on places past the decimal. So our equation comes down to this, 0.0120 squared over 0.19. You see that's important because this actually does come out to a different value. And that equals 7.6 times 10 to the negative 4. That's for the Ka value. Now that's going to be two significant figures, because that's two significant figures down there on the 0.19. All right, does anybody have any questions so far? That's the Ka. I haven't done the pKa yet. I'll get to that in a second. Anybody have any questions? Okay, so at this point, we've got Ka equals 7.6 times 10 to the negative 4. The pKa is going to be the negative log of the Ka. Now, sometimes people get confused about this and they say, well, there's no negative log button on the calculator. Well, what I'm really asking you to do is take the log of Ka and then take the negative of that number. Okay, so when you do this, you end up with, so if we do the pKa, it's going to end up being 3.12. So try this in your calculator. Take 7.6 times 10 to the negative 4 and then hit the log button on it. You should get negative 3.12. If you're taking the negative of that log, you're really just taking the negative of the negative, which is a positive. That's why it comes out to 3.12. I'll talk about the significant figures in a second, but does anybody have any questions about that? Just make sure you can do it in your calculator. That's all I'm asking.
Could you say how to do it in your calculator just like one more time?
I'm sorry?
Could you say how you do it in your calculator just one more time?
Yeah, so 7.6 times 10 to the negative 4 and hit log. Or it depends on your calculator, Emmeline. You might have log. If it's a graphing calculator, you might do log 7.6 times 10 to the negative 4. Or if it's another calculator, you might do the number and then hit log, the log button. I don't know which calculator people have, so it's going to vary. But you all should end up with 3.12 as your final answer. What calculator? Sorry, what calculator have you got, Emmeline?
I have the TI-30X.
Okay, so you'll put the number in, 7.6 EE negative 4.
Okay.
Right.
Got it.
And then hit log, LOG.
Okay, and I got negative, but we turn it into a positive?
That's right, because the P is the negative log of. So you're just taking that negative that you get turning into a positive.
Okay. Thank you.
Is that fair enough?
Yes, it is.
Okay. Does anybody have any other questions about this? Anybody having any difficulty putting this in their calculator and getting that result? Okay. Let me talk a little bit about the significant figures here. Now, when you take a log, let's say we've got, well, one thing you might know, well, let's have a bit of a memory, a jog down memory lane here. Log A times B is equal to log A plus log B. So that's an equation you would have learned way back in college algebra. That's the relationship between multiplying something inside a log and then you add the logs together. So what that means, if you've got, I'm going to take this back here a little bit. I know a lot of you are just tuning this out because you're not interested in significant figures, but I'm going to go through this anyway. But if you've got log of x times 10 to the negative y, then that equals the log of x minus y, because log of 10 to the negative y is going to be, well, actually, that's right. So it'll just be negative y. That'll be the log. So that's actually a counting number. You've got to remember that. Y is a counting number. So the only thing that really matters for the significant figures is the log x. So the x part here is going to determine the number of significant figures, because now we're talking about a counting number, and then this will represent the point part. See, the y here is going to be the 3, and the 0.12 will, or 3 or 4 or whatever it happens to be, and then the 0.12 is going to result from the log of the x here, which is the 7.6 that comes out in the front. So you got a negative here, so that's why it kind of does what it does. But in the end, the bottom line is that the 3 out the front is not a significant figure because it results from a counting number. And any of these decimal places here are going to match whatever significant figures you have in the KA. So that's 7.6, that's 2 significant figures, which means we end up with 2 places past the decimal once we do the log, which results from this being a counting number at the front. So these decimal places end up being the significant figures. So 2 sig figs means 2 decimal places on the log. Does anybody have any questions? Any questions? Okay. So the pKa of this happens to be 3.12 then for the HF. Any questions at all?
Dr. Musgrave?
Yes, Lonnie.
All right. I actually tried to do it on my calculator, and I have a Casio FX 300 ES. I got negative 3.12.
Okay. So
Is it supposed to be negative?
well, that's the thing. You see, when you take the log, you're supposed to take the negative of that value to get because P is negative log of. So you find the log and then you take the negative of the negative, which is going to be a positive. So you have to take that negative and convert it to a positive.
Gotcha. All right. Thank you.
Okay. Now that'll be commonplace when you're finding these logs. The reason we do this is because it's much nicer to be working with numbers between 0 and 10 than it is to be working with 10 to the negative something or 10 to the negative 6, 10 to the negative 5. It just is a lot more convenient. That's why we deal with pKa's and pH's and things. All right, any other questions? Okay. So let's look at an example of finding a pKb. So I told you that Ka's have to do with acids, Kb's have to do with OH minus. Now the only way, if you look at CH3 and H2, you don't see any OH minus anywhere in there. The OH minus actually has to come from the water in the solution. And we have no choice when we're writing these equations to use water here. So when we do that, we end up with OH minus. And the other thing we'll end up with is CH3. Actually, I'm going to rewrite this so I have more room. Let's try that again. So H2O plus CH3 and H2 will give OH minus and CH3 and H3 plus. This usually gives students fits writing this kind of equation. Here's what you've got to understand. The H2O effectively is really a combination of H plus and OH minus. You've got to think of it that way. If we've got the OH minus here, then what's happening here is the H plus is simply adding to the other part. And that's why I've made it CH3 NH3 plus. That's all I've done. So think of it that way. Think of water as being a combination of H plus and OH minus. Does anybody have any questions? Now, this is, you know, this is going to be on the test. You know that I'm going to ask for equations. You know this. You know that I'm not going to let you get away with just being able to slide by on this one. You are going to have to be able to figure this out. So this brings me to another discussion, which I'm going to enter into. Well, I think I might enter into it after I do the, I'll enter into that other discussion about actual equations and stuff after I've completed this example. Okay, so we've got our equation here. We've got initial. Does anybody have any questions about this so far? Can anybody tell me how I know why I know I'm getting OH minus as a product? Does anybody know why I did that to begin with?
Because it's a base.
How do you know that?
Because it's KB.
And what does B stand for, Alexandra?
Base.
Thank you. I appreciate that. That's great. Yes, Alexandra had that exactly right. So that's how I know. That's why I'm doing it. That's why I'm putting OH minus as a product, is because it's KB, where after KB, it actually has that in the question. It's the same situation as we dealt with before. It's 0.30 minus Z, and then Z and Z at equilibrium. We're given the pH here, and the pH is 9.97, but that doesn't help us really get the OH minus concentration. So we're using another relationship here, which I should have actually gone through earlier, but it's this pH plus POH is equal to 14. This comes from what happens if we take H plus times OH minus is equal to 10 to the negative 14, which we dealt with earlier. If we take the log of both sides of that, this is what we end up with. pH plus POH is equal to 14. So that's the relationship. Now the thing is that I've got OH minus, which means that if I've got the POH, then I can find the OH minus that way. So POH is going to equal 14 minus 9.97, which is going to be 4.03. So if I want the concentration of OH minus, it's going to be 10 to the negative POH, which is going to equal 10 to the negative 4.03, which is 9.33 times 10 to the negative 5 molar. Does anybody have any questions? I couldn't just use the pH. I had to find the POH first, and that's the relationship between pH and POH. They always add to equal 14.
So where are you getting the 14 from just exactly?
Well, if you look at the, if we go, I'm going to take this back a little bit here. Was that you, Emmeline, asking that?
Yes, it was. I'm
Yeah,
just a little
okay.
confused.
Do you see up here how, remember how I got that KW is equal to H plus times OH minus, and the KW is 10 to the negative 14, the top of the pH scale?
Yes.
Yeah, so when you take the log of both of that, because log of A plus log of B, sorry, log of A times B is equal to log of A plus log of B. So we take the negative of each of those, we end up being able to say pH plus POH is equal to 14. So that's the relationship between them. That's where the 14 comes from. It's the top it's the top of the pH scale. So that's always going to be the relationship between pH and POH. In the question we were given pH, so we had to be able to find POH somehow, and that's the relationship we're using.
Okay, so will it always be pH plus POH equals 14, or could that change?
No, because 14 is always the top of the pH scale.
Okay.
That's where the 14 comes from.
Okay. Thank you.
Okay. All right, so we end up being able to do this math here. Oops. So the concentration of OH minus was equal to the 10 to the negative POH, which we've just calculated. Now the KB comes back from the original equation as OH minus CH3 NH3 plus over CH3 NH2. Z squared over 0.30 minus Z is what we have here. Now the 0.30 minus Z, if you were to do this using like decimals, it's really effectively 0.30 minus 0.000933. And I'm hoping you can see that if we go by significant figures here, effectively what we're going to have is simply Z squared. Actually, not Z, we'll go with 9.33 times 10 to the negative 5 squared over 0.30. So because there's so many decimal places in that other number, it goes by 2 decimal places. We're just not changing it. It's just not, nothing's happening to it. So the answer we come out with here is going to be 2.9 times 10 to the negative 8 on the KB value. So that you'll get that if you put that in your calculator. That's 2 significant figures, by the way. And then if we take the PKB, it should be 7.54. And again, you'll do that by taking the log and then taking the negative of that value. Remember, it should be close to 8, which it is. That's what you're expecting. Does anybody have any questions?
Can we go back a couple of steps?
Mm-hmm.
So I got the KB, and then you just took the negative log of 2.9 times 10 to the negative 8.
Yeah, I took the log and then took the negative of that value, Alexandra.
Okay, yeah. Okay.
Yeah, there's no button on there to take the negative log. You have to do it in 2 separate steps. You take the log first and then you, right? So often people will try and take the log of a negative number, which is not going to be very useful. You'll end up with an error that way. So that's effectively what we're doing. We take the log first and you take the negative of that log value, and that gives you the PKB. Is that okay, Alexandra?
Yeah, that makes sense. I got that.
Okay. Just out of curiosity, did you try to take the log of a negative number, and that was what was confusing you?
No.
Okay, all right. Sometimes people do that though. I mean, it does happen. It does happen. All right. Any other questions? Okay. Well, I'm sure you're all very interested in what this looks like on the test. But before I do that, I'm going to give you a little bit more information about how to write equations for Ka and for Kb. So because if you know you've got acid and you know you've got base. So again, just reiterating what I said earlier, acid gives H plus and base gives OH minus. I don't think anybody has any questions about that so far, right? I think we're all okay. Okay. Now I'm going to introduce another couple of terms to you here. Conjugate acid. And conjugate acid, to get a conjugate acid, you would add H plus to something. And then to get a conjugate base, we add, we take away, remove H plus. So why have I introduced those two terms? Well, that's because acids generally give H plus plus a conjugate base. And bases generally give OH minus plus a conjugate acid. The term conjugate here, it simply means partner. It's what you get after it's become H plus and something. You get H plus and that conjugate base. And bases tend to give OH minus and plus the conjugate acid. And I've got up here how you get the conjugate base and the conjugate acid. To get a conjugate acid, you add H plus to something. To get the conjugate base, which I didn't spell correctly here, you remove H plus. Okay, so that's going to be good information for these next kinds of examples. So these are writing equations. Okay, so let's say we're looking at Ka and we're given, what's a good example? Actually, I'll do a number of examples here. We'll do, all these. Okay, so these are going to be written for Ka. So you're going to see it, you're going to get the point of what I'm going at here, right? So acids give H plus and the conjugate base. How do we get a conjugate base? We remove H plus, right? So let's go ahead and do that here for the H2CO3. So H2CO3, we take off H plus. I want you to write on a sheet of paper in front of you what else you're getting. The question mark. What else do you get with that? And look, and I want you to, for a clue, I want you to look up here to what I've got here. So acids give H plus in the conjugate base. We get a conjugate base by removing H plus. So what do you get when you remove H plus from that? Okay, does anybody want to tell me what that question mark is? It's kind of related to what we were doing earlier. Yeah, HCO3 negative. So Kate, where'd that negative come from? Can you say, or you?
Yeah, it's because you took out an H plus, and since the charges have to balance.
That's right. Yeah. So it's going to be HCO3 negative. So that negative is going to be important. Do you remember we were doing this earlier, and people were having fits about the positive and negative charges then as well. So nothing's really changed as far as that goes. All right. Let's look at this one. HCO3 negative is going to give H plus and then a question mark. All right. So I'd like you all to try and figure that one out as well. What do you think the other thing is here? Actually, before, don't anybody answer, please. Okay, I'll see if I can create a poll. I'm going to create a poll for this. This will give a really good idea of how people are going with it. Poll. Here we go. give me a second. Give me a second. Do you see me creating this poll? Just out of curiosity.
Yes.
Oh, you do? Oh, okay. Well, actually, it probably doesn't really matter so much. I can't do superscripts and subscripts here, so it's a little bit tough, but you can see that anything in parentheses is going to be a superscript. Okay, that's all right. It's okay. I don't mind that people have seen me create it. Okay. Okay. So what I'm looking for is that question mark. So which one is it? Okay, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. I guess there's 6 of you, 5 of you now who didn't vote. Any reason you're not voting? It's anonymous. No, I'm not going to know who voted for what. Okay, thank you. I'll give you another few seconds. Okay, still 3 of you not voting, but anyway, I think we'll end it there. Okay, so the answer there is the CO3 2 minus, and you can see 9 of you got that, so a little bit more than half, which is good. So let's see how we get that. So you're all okay, I think, with taking the H off. That's not a problem. But think about what the charge has to be in order to make that work. If this is H plus, then plus and then CO3 negative 2 plus 1 plus negative 2 is equal to negative 1, which matches the negative 1 on the other side here. So the charges on each side have to match. So when I say remove H plus, another way of saying that is to remove H plus and remove the H and then take the charge down by 1. And that's what you've got to understand here. Does anybody have any questions? Does anybody have any questions? Anybody still confused about why it's negative 2? Okay. I know 9 of you have kind of got the answer, have kind of got this, I think, so that's good. But a bunch of you are still confused about the charges, I think. All right, let's look at this one, NH4 plus. So remember, that it's going to be H plus and then something, and to get that something, you'll take H plus away from it. I don't think I'll do a poll on this one. Well, yeah, I will. I'll do a poll on this one too. Give me a second. Come up with an answer while I'm doing the poll. You know what I'm gonna do here. I'm so evil because I know exactly what wrong answers people are thinking about, which makes it which makes it, I think, a formidable person to be writing test questions, because I know what confuses people, and I know exactly what distractors to add. I don't think people like that too much, but that's how it is. All right. Okay, here we go. Conjugate base for NH4+. So you'll notice that they're all NH3s. So which one is the answer here? NH3 minus 2 minus 1, NH3 plus, NH3 2 plus. Okay, I'll give you 10 more seconds. Only 12 of you have answered so far. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay. Ending the poll, shared results. Okay. Yeah, so I think that, again, we're getting the same people. I think the same people getting this right has probably got it right earlier as well. You know, that's the thing. It's one of those things, once you get it, you get it. You know, there's no, but obviously, after it takes a while, it can take a while to try and pick up what's going on here. Yeah, but the answer is NH3. And what's happening here, again, you're taking H plus away. So you take the H off and we get the NH3 part, obviously. But let's look at what charge we're expected to have. So that's 1 plus, but that's got to be 1 plus 0. So the charge on the NH3 has to be 0. That's why it's NH3. Does anybody have any questions? For those, especially for those people who didn't get the right answer, I really want you to understand what's going on. I want you to see this pattern. Okay. Okay, so those are Ka equations. Let's look at some Kb equations. These will be fun. And let's see, we'll do and let's see, and what to say? Okay. Now remember, with Kb, we always have to use plus H2O, because that's the only way that we can get the OH minus into our equation. With the Ka, I had the choice of using plus H2O or not. I chose not to last time. But let's look at this one. CO3 2 minus plus H2O. Okay, so we know we're going to get OH minus. So CO3 2 minus gives H2O plus OH minus plus question mark. So I'll create a poll while you're doing that. Okay, so in this time we're looking for a conjugate acid. And it's a conjugate acid for CO3 2 minus. And let's see what it's going to be. Is it going to be Okay, let's try that. All right, save. Okay. I didn't mean to do that. Okay. See if you can figure that out. The conjugate, so we're looking for whatever's forming with the OH minus here. Let's see if you can get the answer to this. Okay. About, let's see, one of you's left, but so there's still 10, okay, 12 people have voted. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay, I'm going to end the poll here. I'll share the results. Okay, so HCO3 negative. It's interesting, isn't it, how it's always seems to be 9 or 10 people who are getting these right. I think it's the same 9 or 10 people, be completely honest. And the rest of you are still kind of struggling with this. I think you're guessing. So how do we do this? Okay, again, look at what we're getting here. Bases, we get OH minus in the conjugate acid. And in order to get a conjugate acid, we would add H plus to this. And if we add H plus, then of course we get the HCO3, but then we need to have the right charge here. So the plus would take the -2 and make it a -1. But look at what we're getting here on the charges. -2 is equal to -1 plus -1. So the charges always have to balance out. I think that's what people have trouble with, is this algebra here. It's just figuring out the charge, knowing that those charges have to match. It's not a difficult concept, but it just seems to really turn people on their heads with it. I don't know what it is. Does anybody have any questions? I'd really like to be able to get this sorted. Does anybody have any questions? You know, I'm really talking to those people who are having real difficulty with this. And I know that half of you who are on this call are still having trouble with it. I know you are. I know half of you aren't. I know half of you have figured this out. So I'm just talking to the other half of you here who are obviously not getting this. Does anybody have any questions that could help here? Okay. I'm not going to do a poll for this one. I'm kind of running out of time here, but let's say we do CH3OH plus H2O, and we're getting OH minus, oops, OH minus and something. Let's see what that something is. All right, excuse me, write that down, please, and then see if you can come up with an answer. Look at the clue I've given you above here. If we're talking about bases give OH minus and a conjugate acid, and the conjugate acid you get by adding H plus. So, all right, so this is what you should have. So CH3OH2 plus. So that's what you get when you add H plus to CH3OH. Anybody have any questions? Okay. All right, let's look at HCO3 minus plus H2O. We get OH minus, and I want you to figure out what you get from that as well. Okay, the question mark should be H2CO3. So that's what you get when you add H plus to HCO3 minus. That's the conjugate acid. All right, does anybody have any questions? Honestly, I feel like there's half of you who do not have this at all. Now I don't, let's see, I might be able to do a poll for that. I think I've already got one. Let's have a look. Stop sharing. Let's go back to poll. Okay. So we're just talking, when I say topic, I'm talking about the equations here. I'd like to get an idea of where I'm at with this. Okay, another, I'll give another 5 seconds. 5, 4, 3, 2, 1. And there's 3 of you who don't want to respond. Okay. So again, yeah, see, I kind of figured it right. About half the class has seems to understand this, but yeah, the rest of you seem to be a bit foggy on it. Okay, so let's look at how we might deal with that. So there's your there's the poll here. Okay. All right, let's talk about the kinds of questions that you'll see. Yeah, unfortunately, we can only deal with the people who are actually on the call, as well as a whole bunch of people who didn't come today, who are thinking they'll figure it out as they go, but I don't know how successful they'll be. I think the people who are here today, who are understanding it, have gotten something from it. But there's going to be a little bit more to this. Okay. So you can see that there's actually 4 questions, 8 and 9. For questions 8 and 9, there are 4 possibilities that you could pick up here. And you can get any of these. So you can have Ka given a pH. We can have Ka given POH. Those are the 2 that are actually there. We could have Kb given pH, or we could have Kb given POH as well. If you've got Ka given pH, you don't use the actually I'll do this as a table here. And if you've got Ka given pH, then you've got the H, which is the H plus. So you don't use the pH plus pOH is 14. If you've got Ka and you're given pOH, then you would. If you've got Kb given pH, you would. But if you got Kb given pOH, you wouldn't. Remember that pH is from H plus and pOH is from OH minus. And acids give H plus. So Ka is acids, that's H plus. And Kb is bases, which gives you OH minus.
I have a question.
Yeah.
When you say use the pH plus OH, does that mean where you took 14 minus what was given?
That's right.
Okay.
Yeah, but that's what I'm talking about. I want to make it universal for these. That's why I started with the initial equation here. But if you got Ka, then you would have to subtract the pOH from 14 to get the H, to get the pH. Do you see what I'm saying? And
yeah,
then,
that makes sense.
Yeah, then if you've got the Kb and you're given the pH, you want the OH, so you'd have to do pOH equals 14 minus the pH. So that shows you what you'd need to do there. And then that's two of those questions, and you could be any of those you could get for that. And then we've got the dreaded reaction questions down here as well. So that's going to be fun for you too. All right, so if this is something you're struggling with, I honestly feel like doing these questions 8 through 11 again and again would be helpful to you. And if you're not getting it, you have to come see me, talk to me, or go get help from a tutor on tutor.com. Either way, but you need to seek help if you're not getting these problems correct. Does anybody have any questions? Okay, well, we'll leave it there here for today, and I will talk to you all later on. All right, I'll see some of you in about 15 minutes though for lab. Okay. Good luck, everybody. I will talk to you later. Sydney, are you here for a reason?